Assalamu alaikum viewers. I am Farrukh Nadeem with a new tutorial. Today's tutorial, just like last time when we did a tutorial on a cylindrical job, today's session will also be about cylindrical work, meaning we will be working on a rotary job. I am starting with a new file, and in this new file I have set the job as a rotary job. Its length is set to 12 inches and the diameter to 5 inches. The remaining G0 position is set in cylinder X, and I set the 1-1 datum to the bottom left. After that, its orientation comes up, which is along the X-axis. Once all this setup is complete, we get an area AA area which we have to design. So I will begin just like last time when we used roughing from the gadgets. In roughing, the last command we used was Floating tool. Today we will do a spiral layout. What does a spiral layout basically do? As the name suggests, it will design in a spiral form around the cylinder job that we are about to create. So if we had to do all these things ourselves, if we had to calculate everything manually, it would involve a lot of calculations, a lot of geometry, and we would have to draw a lot of references in it. But in Aspire, we have this gadget where we can design a spiral layout, and if we discuss the features available in the spiral, the first thing is the spiral parameters. That is, the number of starts here you specify, how many spirals you want to create. All of these are based on your tool diameter or the job diameter. For example, as you can see here, the job appears in a cylindrical form. So according to that, we will design and plan the starts. After that, there is use spiral pitch or spacing. Now, there are two options. One is that for the spirals we are about to create, we can specify the pitch value. That is, the distance from the center of one spiral to the center of the next spiral, which we will enter here. The second option we have is spacing between strands. Now, these strands that are being created, look here, this is their position. If you set it to strand, it specifies the pitch as center to center. But if I talk about this option, it means from one line to the next. That is, the distance from the edge of one strand to the edge of the next strand. That distance needs to be specified here. Similarly, offset from start means how far from the start the strand should begin, and offset from end refers to the distance from the end. In the same way, for the job that is the cylinder or rod we are using, how far from its end should the strands finish. Here the values are currently set to 1 inch, 1 inch, 1 inch. Then there is the twist direction. Here we have to select ourselves whether we want a right hand twist or a left hand twist. After that, there are the cobs, as we saw in the last assignment as well, that is where the strands are starting from. At the starting points, a group will be placed both at the start and at the end. After that, we have the cylinder diameters here. So the ones we added earlier, those same values will be used here. After making this selection, for now I am keeping its size at 8 and then click OK. As soon as I clicked OK, it showed me the total number of revolutions of the spiral, that is the total number of turns the spiral will make here, which is 2.415. After clicking OK, notice that we have some lines here. These are the lines that will help us create the spiral on the cylinder. Now I will move this to the tool side, and let's look at the material once the same diameter appears, the same position that we adjusted earlier. Click OK. After that, you need to select Profile Toolpath. In Profile Toolpath, we need to select these objects and then select the tool. For the tool, I'm using a 12 mm tool here with a cut depth of 0.2. On means that we are going to calculate it at the exact position of these vector designs. As soon as I calculate it on position, you can see in the preview that it has created both the tool route and shown you the cutting route as well. That is, the path the tool will follow during the job. So there are two things. One is the tool's traveling path and the other is the cutting path. Now, as soon as I click preview all, notice how beautifully it has completed the job in a spiral form. Look at this. If I change the colors here, it will look even more beautiful. See, I will close this here and go back to editing. The profile 1 tool path we designed, I'm going to its editing. The purpose of going to its editing is to add the cobs that we set here. See, I have selected the 2D view, and look, these two lines here. Which lines are these? These are the ones where we plan the cobs at the start and end. We will select them here. So whether you use the lasso tool or just hold shift, we are adding these two lines. When you select these two lines, both will be selected with a single selection. I have included them, reset the preview and previewed again. Notice that now the cobs have also been designed along with it. So see, this job has been created very beautifully. Now that the tool is complete, I'll go to 2D and use the same option. Again, go to wrapping, then spiral layout. After going to spiral layout, now I will change its direction. All the other settings remain as they were. I turned off the cobs because we've already created one. Click OK, and in the same way it has given us the other direction as well. So viewers, notice this. The purpose of doing both of these things is this. You saw one design here, and now as soon as I go to the tool prof, I will go to it, and along with that I am also adding these lines by holding shift. And when you click calculate, pay attention here when I do a research preview and then preview again, you can see a very beautiful design right here in front of us. Take a look at this. So the spirals have started to intertwine with each other in opposite directions. And if you want to make them separately, like here, if I bring this into 2D, then I can take one of our vectors and here I can remove it from the vector set. If you do a research preview or preview all, then this option becomes available to you. If I unwrap this, you'll see that by unwrapping it, you get this result. So when this design is unwrapped, after matching with each other, it creates continuity. This is exactly how it appears on the cylinder job. Now, let's take it one step further. Once you have designed the toolpath here, after designing the toolpath, you'll see we have the option summary of all toolpaths. As soon as you go to the summary, it will tell you here how much total time this job will take. This entire job will take 12 minutes. All right. So this is one thing we get here. Secondly, we have this option here, create job sheet. You can also attach a job sheet here along with it. So where will the job sheet be created? I saved the job sheet as a new summary at this place, and we will get the job sheet here, the one that you had designed. So as soon as I am on the job sheet here, you can see that its complete details are available here. This is its layout. If you can see here, the material border is shown here and all its positions are displayed. And here regarding the toolpath, it has specified that a ball nose tool will be used and the job will be completed in this much time. Here it has provided the toolpath info. The toolpath type is 2D profile. The toolpath used is freed reammer. This is set for plunge rate and this is set for spindle speed. If we go into tool info, it basically gives the complete setup for this job. So when you save this file and then give the design plus the program and the summary to your operator, it will be very easy for them to perform this job. Now after this, our last process is the toolpath to toolpath. As soon as you come into the toolpath, you'll see that there are some options available here. First of all, there is select toolpath. The first option given here is selected toolpath, visible toolpath to own file, visible toolpath to multiple files. So at this time, we are only going to work with this selected toolpath. You select the post processor here. For example, I set it to MEC here. The post processor MEC Inc., or whichever post processor your main supplier, the one who provided you with the machine, will tell you which post processor should be used with this machine. If you want to send the job directly to the machine, then turn this on. Otherwise, turn it off from here and save the toolpath. As soon as you save the toolpath, you can save this file anywhere you want. Suppose I'm saving it here. The file has been saved. And here you can see that the file has been created under the name profile. In this way, its G code has also been generated. So viewers, I hope that in today's session, you have learned something new again, and you are definitely finding it useful. Many people requested that we work on 3D rotary, and that's why I have started this series. God willing, we will also be starting with Teddy next, which will be included in both 3D rotary and 3D plane. Please allow me to take my leave now. Take care of yourself. Goodbye.